Good morning, good afternoon, good evening, everyone. My name is Raghunandan, and I'm a technical lead from HP ERT switching team. Today, in this elevator pitch, I'm going to talk about a new feature we are going to release as a part of 10.16 release, which is known as Hibernation for AOS-CX switches. This is an introductory session, as mentioned by Shobana, and the detailed TOI of this feature will be posted in the Edge portal soon. Please follow the Ed portal for the updates. So let's get started to know more about this feature. Meantime, please use the Q&A section to post your queries and not the chat section. Starting from 10.16 release, network administrator now have the ability to configure hibernation on AOS-CX switches. Hibernation is essentially a low power mode when the switch becomes non-functional, very similar to when it's powered off. This feature can help with energy efficiency and hardware longevity when the switch is not in use for extended periods or like out of business hours or in the night time, so etc. So with the initial release of 10.16, there are two hibernation modes are supported and configurable. That is hibernation now and hibernation periodic. Periodic means you can configure or schedule the hibernation on multiple specific days or weekly or monthly or weekends, etc. So let's see one by one in detail. So here you can able to see the flow of Hibernate now. So in this switch will, as soon as you configure the hibernation, right, switch will enter the hibernation mode and it will wait for the hibernation timer to expiry. And once the hibernation timer expired, right, switch will boot up automatically and start operating normally. So that's what the hibernate now option is for. Means as soon as you configure the hibernate now with the command. So let's see the configuration forward. So once you configure Hibernate now, the switch will immediately go to the hibernation mode and uh, it will wait for hibernation timer to expire. And after that, switch will boot up and start operating normally. So if you see the configuration, right? So there is a command hibernate now, and you have to specify the end time here. So hibernation end time is a must-have prerequisite to configure the immediate hibernation. The switch cannot be hibernated if the end time has not been configured. The end time must have at least 5 minutes interval from the current system time to allow for the system to shut down safely. So we need to make a note on it. So if in case the specified end time does not exist or in complete format, or if it is not meeting the requirements, then an error message will be displayed on the console and the hibernation will not take place. And once you execute this hibernation now with the proper end time, so it will prompt you to, it will ask you, do you want to save the configuration? You need to save the configuration before you put the switch into the hibernation. So you have to give as, and after that, the switch will go to the hibernation. Next, this is the flow of periodic hibernation. In this, actually, it is unlike hibernate now, right? As soon as you configure the hibernation, switch will not go to the hibernation, but you can configure recurring hibernation here. And like it allows the recurring days to set as daily, weekdays only, weekends only, or any individual day of the week like Monday, Tuesday, Thursday. So separately you can schedule each day, each specific day as well. And it is possible to have 7 different profiles catered for each individual day of the week, or different profile for weekdays, weekends, according to the business requirement. What will happen in the periodic hibernation? So once you configure the periodic hibernation with the required schedules, so you need to save the configuration. So after that, the switch will wait for the first hibernation schedule. And once it hit the first hibernation schedule, it will enter the hibernation and it will again wait for the hibernation timer to expire. Once the hibernation timer expired, it will switch will boot up automatically and start operating normally. And again, it will wait for the second hibernation schedule and so on. The configuration here is as follows. you need to configure hibernate periodic. That will enable the hibernation periodic, that is recurring hibernation, it will enable. So once that is enabled, you need to create the profiles. That means how you want to configure it. Means you want to configure it as daily, or you want to configure it as only for the weekdays or only for the weekends. It is up to as per the business requirement. So you can configure the profiles, and you have to set the time period. Means when you want the switch to go into the hibernation, means start time and the end time you need to configure. So this is how these are the two modes available as of 10.16, that is Hibernate Now and Hibernation Periodic. And these configuration can be configurable via the CLI and REST as of 10.16 release, and it is supported on VSF and standalone switches. If you consider the use cases in a campus environment and small offices, energy conservation during the periods of inactivity, such as overnight, weekends, and holidays, can significantly impact both energy cost and the environmental footprints. Customer benefits by carefully planning this, implementing energy efficient strategies and at the access layer, and also the TOR part, right? Means you cannot hibernate the distribution or aggregation layers. But if you consider the access layer and the TORs, organization can reduce the power consumption, optimize energy use, and ultimately cut down the cost as well. The supported platforms are 6300 standalone also supported, and also with the VSF it is supported, and 8325H and 9300S are supported, which can be used as a TOR switches. Next, if you consider the exit hibernation, what and all the options available for the exit hibernation once the switch enter to the hibernation mode, right? So how the switch will exit the hibernation. So one is, as usual, the normal thing. The switch will wait for the hibernation timer to expire. So once the timer expires, switch will automatically boot up and start operating normally. So in case if there is a need, and there is a rare need of uh, force exit the hibernation. So you have configured the hibernation switch, enter the hibernation, but so for some reason you need to exit the hibernation. So there are two options available. One is you can press the mode button, and the other one is you can power cycle the switch. With these two options, you can exit the hibernation forcefully. Next, we're going to see the power consumption and things to remember, some of the things to remember while configuring the hibernation. So during the hibernation, let's see some of the important status of the switch hardware while when you configure the hibernation. So PoE will be turned off. So there is no power over Ethernet which is supplied to the PDs, right? So that is not operating. It will be turned off. CPU is powered off. There is no traffic flowing across the switches when you configure the hibernation and switch gone into the hibernation state. Fans are turned off, and in case of two power supplies, that is redundant power supplies, if you have a 6300 switch or 8325H switch, right? If you have two power supplies on the switches, so in that case, first power supply, the primary power supply will be in the on state, and the secondary power supply will go to the off state during the hibernation. In case of 9300S, both the power supplies remain on for the redundancy purposes. In case of 6300, if you have a single power supply, it will be in on state during the hibernation. And if you consider the LED and logs, event logs, what and all the event logs will be generated, and what is the LED status. In a hibernation mode, hibernation LED, which is also known as a global status LED, fades in and out in green color to indicate the hibernation. That is the LED status. And event logs will generate when the hibernation is initiated, enabled, and disabled for all the events whatever you configure the hibernation, you delete the hibernation configuration, or the switch is entering the hibernation or exit from the hibernation, switch is rebooting because of the hibernation. For all the events, the event logs will be generated with the timestamps, which will help you to troubleshoot in case of any issues. In addition to that, boot history tracks the hibernation and provides logs for entry and exit details. So if you go to the switch and you show boot history, right? So you can able to see the logs which is related if the switch is rebooted, if the switch has gone to hibernation and rebooted back to start operating normally, you can able to see the logs which is related to the hibernation. The last boot reason it is mentioned as it is because of the hibernation and with the timestamp of entry and exit details. And some of the points to note, wake on LAN is not supported, and if the same switch configuration are expected to be persistent after the wake up from the hibernation, the user must manually save the current configuration to the startup configuration before entering the hibernation command. So we need to make a note on these points when we work with the hibernation. Let's have a look into the power consumption and energy conservation. Power consumption of the switch is measured as sum of the PSU power loss, system power, and PoE power. PoE power is the direct power utilized by the PD or PoE devices which is connected to the switches. On the other hand, the system power is the power utilized by the switch itself, and the utilization is based on whether the system is running on idle or link up or during the switch carrying 10% of the traffic, or it is fully utilized, that switch is carrying 100% of the traffic. So on the right hand side you can see the graphical representation where it is simple to understand the power consumption of the switch with the different switch states. That is, when the switch is carrying 100% of the traffic, the nominal power consumption of the switch will be 184 watts. And if the switch is running with the 10% of the traffic, the nominal power consumption will be 173 watts. And if the switch is up and in idle state, then the power consumption of the switch will be 115 watts. And if the switch is up, links are up, connected, but there is no traffic flowing across the switches, then the power consumption of the switch will be 168 watts. The point to note here is the hibernation. So you can see when the switch is put into hibernation, then the power consumption of the switch should be 37 watts. So you can see the significant decrease in the power consumption here. Let's make some assumption to understand the impact of the hibernation on power savings. Assume a 6300 switch with JL670A power supply unit on it. And we are assuming an environment where the switch can be powered down or hibernated for 5 hours at night during the working days of the week. So as we have seen in the previous slides, the nominal power consumption where the switch is handling the 100% of the traffic, the power consumption of the switch is 184 watts. So let's, if we calculate the energy consumption for 5 hours of the day, we can see 920 watts per hour consumption by the switches. And if we calculate the same for one working week, then we can see the power consumption of the switch or the energy consumption of the switch will be 4600 watts per hour. Why it matters? This is the wasted energy when the devices are not in use. You can multiply by the number of switches in your network and you can see the unnecessary cost and carbon impact add up quickly. So with hibernation feature from 10.16, switch can be put under periodic hibernation for these 5 hours. You have seen in the previous slide the power consumed during the hibernation is 37 watts when the switch is put under the hibernation. So when you calculate the energy consumption for 5 hours of a day, you will see the switch energy consumption is 185 watts per hour, and if you calculate the same for one working week, it will become 925 watts per hour. In addition to that, in the below table, you can see the power savings of other traffic scenarios, what we discussed in the previous slides. In the different switch status, what is the instantaneous power consumption? And if we compare the same with the hibernated the power consumption during the hibernation, you can see the percentage of reduction in the energy. If we consider the idle state and when we compare it with the hibernation mode, you can see there is a gradual decrease of 14.13 percentage of reduction of energy for this is the percentage of power saving per working week. So you can see 14.13 percentage for one particular switch, and same calculation is carried up for link up, 10% of the traffic and 100% of the traffic, and you can see 16.24, 16.44 and 16.64 respectively. Here, to highlight energy saved per switch per week, that is 5 days for a single switch, up to 3675 watts per hour. This is the energy saved per a switch for a single switch per week, that is for 5 days for 5 hours, right? So percentage reduction in power consumption is up to 16.64 percentage. This is the significant amount of reduction in the power consumption, and you can multiply that by the number of switches, and you can see the unnecessary cost and carbon impact add up quickly. Thank you all for your time. This concludes Hibernation elevator pitch. For more details, I encourage you to watch the complete TOI videos. Thank you.